Hello, my little mathematicians. Today, we're going to do applying operations with rational numbers. Now, we say rational numbers because it includes fractions and decimals. When we're doing these types of word problems, I want to point out that before you can add, subtract, multiply, or divide, both numbers need to either both be decimals or they both need to be fractions. Okay, so you want to either change them both to decimals or both to fractions and then add, subtract, multiply, or divide them. So let's go ahead and take a look at this first example. It says Elaine bought 3 4/5 pounds of apples. Okay, so 3 4/5 pounds of apples for $1.99 per pound. And 3/4 pounds of pears for $2.25 per pound. And bananas, she bought 3 2/3 pounds of bananas for $1.75 per pound. All right, there's quite a bit of information here. So first of all, I need to figure out how much did she spend per each item. Okay, well, let's focus on the apples first. She bought 3 4/5 pounds at $1.99 per pound. Let's go ahead and change these to both be decimals. That's already a decimal. 3 4/5 is 3 point something. I want to find out what 4/5 is as a decimal. So let's do some scratch work off to the side. To change a fraction to a decimal, you could take the top divided by the bottom. Okay, so 5 goes into 4, it can't, so add a decimal and a 0. And 5 goes into 48 times, and it went in evenly. So it's 0.8. 4/5 is the same as 0.8. Now, if you didn't want to do it that way, you could sometimes change a fraction to a decimal if that denominator can become a power of 10. And in this case, it could, because 5 times 2 is 10, so do the same thing on top. Multiply the 4 times 2, and 4 times 2 is 8. And you get 8/10. And 8/10 is just 0.8, right? Because it's 8 in the tenths place. So that's one number after the decimal. So 0.8 is the same as 4/5. Now that I have how much you bought times how much it cost per pound, and this is how many pounds you got, and they're both in terms of decimals, I can go ahead and multiply that out. So you have 1.99 times 3.8. When you're multiplying with decimals, you put the one with the most number of digits on top. This has 3 digits, this has 2, and you don't have to worry about lining up your decimals. You multiply like normal. You'd have 8 times this, times that, and then you move on to this number and you go 3 times this, times this, times this. So let's go ahead and do that. 8 times 9 is 72. 8 times 9 is 72 again, plus 7 is 79. 8 times 1 is 8, plus 7 is 15. Now the 8 is all used up, and we're moving on to the number that's in the tens place, the 3, because we're ignoring those decimals for right now. We're just multiplying like normal. So I put a 0 placement holder here so that now I'm in the tens place. And 3 times 9 is 27. 3 times 9 is 27 again, but plus 2 is 29. And 3 times 1 is 3, plus that 2 is 5. Make sure that your columns are lined up straight so that you add the right things. So now when I add these, 2 and 0 make 2. 9 and 7 make 16. 1 and 5 is 6, plus 9 is 15. And 1 and 1 is 2. 2 and 5 is 7. Now I said that you ignore the decimals when you multiply until the very end. So what you do is there's 2 numbers after the decimal here, 1 number after the decimal there, for a total of 3 numbers needed after the decimal in your answer. So 1, 2, 3 places over means that it was 7.562 for apples. Hello, I want it in terms of money, and we don't do money with 3 places. We go out to the hundredths place. So That too tells this 6 to stay a 6. So it's $7.56 that I spent on apples. Let's go ahead and take a look then at how much we spent on pears. Well, I bought 3/4 pounds of pears at $2.25 per pound. I need to change them both to decimals. Some of you guys haven't memorized that 3/4 is 0.75. That's fine. If you didn't have that memorized, you could take the top, divide it by the bottom. 4 goes into 3 0 times, so add a decimal and a 0. But 4 can go into 30 7 times because 4 times 7 is 28. When you subtract that, you get 2. Bring down another 0, and 4 goes into 20 5 times because 4 times 5 is 20. When you subtract that, you get 0. So you got 0.75 for 3/4. You also could have gotten that denominator to become a power of 10. It can't become 10, but it can become 100 because 4 times 25 is 100. So do the same thing on top. 3 times 25 is 75. So you have 75 hundredths, which is 0.75. Now that we have them both in terms of decimals, let's multiply. You have 2.25 times 0.75. Sometimes that I don't forget about the decimal, instead of counting how many decimals there should be at the end, I like to do it at the beginning. So 2 numbers after the decimal here, 2 numbers after the decimal here, for 4 numbers after the decimal in my answer. Now let's go ahead and multiply just like I did up above for that one. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 2 is 10, plus 1 is 11. Now I used up the 5, so I'm going to move on to the 7 in the tens place. So put a 0 placement holder, and now do 7 times all the numbers. 7 times 5 is 35. 7 times 2 is 14, plus 3 is 17. And 7 times 2 is 14 again, plus 1, this time is 15. Add down. Make sure your columns are straight. If not, sometimes it helps to draw lines in between them to keep them all lined up. 5 and 0 is 5. 2 plus 5 is 7. 1 plus 7 is 8. 1 plus 5 is 6. And bring down that 1. Now I said there needs to be 4 numbers after the decimal. So 1, 2, 3, 4 puts me right there. 1.6875 for pears. And again, we're talking about money, so you only need to go 2 places. So that 7 tells this 8 to bump up 1. So now it's $1.69 that we spent on pears. Remember, if the number behind the one you're focusing on is 4 or below, it tells that number to remain whatever it was. If the number behind it is 5 or above, then it tells that one to bump up 1. Okay, let's move on to bananas. Bananas was 3 2/3 pounds times $1.75 per pound. So I know that it's 3 point something because 3 is a whole number, and I just need to figure out what 2/3 is as a decimal. So I would take the top, divide it by the bottom. 3 can't go into 2, but add a decimal and a 0. 3 goes into 20 6 times. When you subtract that, you get 2. Bring down a 0. 3 goes into 20 6 times again. When you subtract that, you get 2. Are you seeing a pattern? Bring down a 0. 3 is going to go into 20 another 6 times. This 6 is just going to keep going and going and going. So since it's a repeating decimal, instead of changing them both to decimals this time, it might actually be easier to change them both to fractions for this one. So this is already a fraction. Let's change the 1 and 7.75 to a fraction. That's 1 75 hundredths. When you're multiplying with mixed numbers, we need to change those mixed numbers to improper fractions. So you keep the denominator the same. And then to get the numerator, you multiply the denominator and the whole number and add the numerator. So 3 times 3 is 9, plus 2 is 11. Okay, this one, your denominator will stay the same. So I could keep it as 100 right now. But can I reduce that fraction, 75 over 100? You can by 25, right? Because otherwise, like this number just might be ginormous. So let's reduce that first. And you have 1 and 75 divided by 25 is 3, and 100 divided by 25 is 4. Now, isn't 1 and 3/4 so much easier to change to an improper than 1 and 75 hundredths? Because then you would have 175 over 100. That'd just be way too big, right? I like to do this one instead. So let's keep the denominator 4. 4 times 1 is 4, plus 3 is 7. So much nicer than 175 over 100 if I were to have done it the other way. Okay, can't cross cancel. Can't cross cancel. Sad day. So you multiply across. 11 times 7 is 77. 3 times 4 is 12. So I'm going to take the top, divide it by the bottom. 12 can't go into 7, but it can go into 77 6 times because 12 times 6 is 72. When you subtract that, you get 5. Now, there's nothing to keep bringing down, so I'm going to add a decimal and a 0, which I can do because 77.0 is the same as 77. So bring down a 0. 12 couldn't go into 5, but it can go into 50 4 times because 12 times 4 is 48. And when you subtract that, you get 2. Bring down another 0. I can keep adding as many zeros as I want, by the way. 12 goes into 21 times because 1 times 12 is 12. When you subtract that, you get 8. I only need to go one more time because I'm talking about money, which is 2 places. And when you're rounding, you always going to want to go one more place further than what you need. So 12 goes into 80 6 times because 12 times 6 is 72. And when you subtract that, you get 8. Okay, so let's go ahead and just stop there. And you get 6.416. Now that 6 tells that 2 to go, or sorry, it tells that 1 to go up to a 2. So you spent $6.42 on bananas. Now that I figured out how much I spent for all my items, I can figure out my other questions, okay? So again, you spent $7.56 on apples, $1.69 on pears, and $6.42 on pears. So they want to know, all right, well, if you brought $20 with you to the store, how much change did you get? Well, first of all, I need to figure out how much total did I spend. So you can put like bought or spent here. We need to figure out, okay, on apples, I spent 7.56. And now when you're adding, you do need to line up your decimals. Okay, so apples was that much. Pears, I spent $1.69. And on bananas, I spent $6.42. Okay, so let's go ahead and add all those together to figure out the total amount of money that I spent at the store. 6 and 9 make 15 plus 2 is 17. And then 1 and 5 is 6. 6 and 6 is 12. 12 and 4 make 16. 1 and 7 is 8. 8 and 1 is 9. 9 and 6 is 15. Don't forget to bring that decimal down for your answer. So you spent a total of $15.67 at the store. So if you gave them $20, you need to subtract those to figure out how much change you get. So you can't take 7 from nothing. So I need to borrow from the 0. That becomes a 9. And since there wasn't really anything there, I need to borrow from this one. That becomes a 9. There wasn't really anything there either. So go next door and borrow from that one as well. Now you can add the 1 there. So you have 10 minus 7, which is 3. 9 minus 6, which is 3 again. 9 minus 5 is 4. And 1 minus 1 is 0. So you should get $4.33 back because you spent $15.67 and you gave them a $20 bill. Congratulations. That was a tough problem. Let's go ahead and take a look at example 2. I promise it's not as bad as that other one. It says, Orlando earned $92.25 washing windows on the weekend. He worked 3.5 hours on Saturday and 6.75 hours on Sunday. If Orlando charges the same amount for every hour he works, how much does he earn per hour? Okay. Try to think about what you want to figure out for this problem. I think that if you talk about the total money earned and you divide that by the total hours that you worked, that will equal how much you earn per hour. Right? If you take the total amount you earned, you divide it by how many hours you worked, that tells you how much you make per hour. So let's go ahead and substitute in what we know. Well, we know that Orlando earned a total of $92.25. We want to divide that by the total hours he worked, which he worked 3.5 hours one day and 6.75, line up your decimal because we're adding, on another day. Okay, 0 and 5 is 5. 5 and 7 is 12. That's 9 plus 1 is 10. Bring down your decimal. So he worked a total of 10.25 hours. And we're going to take that and we're going to divide those two in order to figure out how much you earn per hour. Well, whatever comes first goes inside the house, and whatever comes second goes outside the house, right? This divided by that. You can't divide by a decimal, so move it over, which means you need to move it twice inside the house as well. So you have 1025 into 9225. Okay. Let's just go ahead and put a comma there so we see that that's 1,025. Can 1,000 go into 9? No. Can it go into 92? No. Can it go into 922? No. So now you have 1,025 into 9,000. Well, how many times? I don't know my thousands times tables, but 1 goes into 9 how many times? 9 times. So let's see what 1,025 times 9 actually is. That's 45, 18, 19, 20, 21, 22. 9 times 0 is 0, plus 2 is 2. 9 times 1 is 9. Look at that. It went in perfectly evenly. So we got an answer of 9, which means you earn $9 per hour. If you solved all those without any trouble, congratulations. Those were tough problems, guys. Okay, the main thing is, remember, you want to either change them both to decimals or both to fractions before you get started. When you're multiplying, you don't need to line up your decimals. You just count how many there were, 2 here, 1 here. So that's a total of 3 for your answer. When you're adding or subtracting, you do line up your decimals. And when you're dividing, you can't divide by a decimal, so you move it in the divisor. And however many times you moved it in the divisor, move it the same amount in the dividend. Congratulations, my little mathematicians. This was a hard concept. I'm so proud of you.